soften slowly. Let the noise of the day move further away with each breath. You do not have to listen to every word that follows. The voice will keep going gently. Tonight we are going to drift up and away from the earth, out into the deep quiet of space, to follow the long life of a star from its birth in a dark cloud of dust to its slow and luminous end among the other suns. This is the Circadian Institute. We meet here in this quiet hour to travel together towards sleep. The journey is always slow, and the destination is always somewhere old and unhurried. Tonight, we are going to the quiet science of the life of a star. How a star is born in the cold dark between the worlds, how it burns steadily for billions of years, and how, in the end, it gives its light and its dust back to the night. Subscribing keeps the nights of rest within easy reach. There is nothing to learn tonight, and nothing you must remember. This is a slow drift through the life of a star, told as a place to rest. You only have to listen and let the deep quiet of space settle around you. Every star you have ever seen was born, lives, and one day ends over spans of time so vast they are hard to hold in the mind. Tonight we will follow one star through its whole long life. We will watch a star kindle in a cloud of dust, burn for billions of years, swell into a giant, and scatter its light back into the dark. Each thing is true and set down without hurry. Settle in. Close your eyes whenever you like. Let the voice become a slow path out among the stars until you are asleep. You do not need to be awake at the end. A star does not begin as a star. It begins as a cloud, a vast, cold, dark cloud of gas and dust, drifting in the space between the stars that already shine. These clouds are enormous, light years across, and made mostly of hydrogen, the simplest and oldest gas in the universe. They are the nurseries where every star is born. They are also among the coldest places that exist, only a little above the absolute cold of empty space, far below anything we could survive. Nothing seems to be happening in them. And yet within that stillness, the seeds of suns are waiting. Here and there the cloud is a little denser, a little heavier, and gravity has begun slowly to take hold. Tonight our star begins here, as a faint thickening in a cold, dark cloud, wandering in the silence. From this quiet nothing, a sun will come. Left alone, a cloud might float unchanged for ages, but clouds are rarely left alone. A passing shock or the slow squeeze of the galaxies turning presses the gas a little closer together. Once a patch grows dense enough, gravity wins. The gas begins to fall inward toward its own center, pulled by its own weight, gathering ever more of the cloud as it goes. It is a slow avalanche across the void. The falling gas grows denser, and denser gas pulls harder still, so the collapse quickens upon itself, century after century. A great cloud rarely makes a single star. It breaks into many falling knots at once, so that a whole cluster of stars is often born together from one collapsing cloud. Our knot of gas is one among many, falling quietly inward in the dark. At its heart, where the gas piles deepest, something is beginning to grow warm. As the gas falls inward, it cannot fall in a straight line. The cloud had a faint turning, and as it shrinks that turning grows faster, the the way a spinning skater draws in their arms and quickens. So the falling cloud flattens into a slowly spinning disk with the growing core at its heart. Around that core, the disk turns the gas and dust from which one day planets may form. At the center, the gas is pressed harder and harder by everything piling onto it, and whenever gas is squeezed, it grows hot. The heart of the cloud begins to warm and to glow. It is not yet a star. It makes no light of its own from within. It glows only with the heat of its own falling, like embers warmed by being pressed together. This warm, growing, glowing heart has a name. We call it a protostar, a star in the making, still gathering itself out of the dark. The protostar grows for a long time out in space, often 100,000 years or more. Wrapped in the thick cocoon of dust it is still pulling in. From outside, little can be seen. The dust hides the warm heart within, glowing only in the deep infrared, a secret warmth buried in a dark knot of the cloud. But the young star is not quiet. As it spins and gathers, it flings great jets of gas out from its poles, twin beams shooting away into the dark for light years. These jets carve glowing caverns in the cloud and announce to anyone watching that a new star is forming here, deep inside the dust. Still, the core grows hotter, squeezed by all the weight around it. It is climbing toward a threshold, a temperature at which something entirely new will begin. At last, the core reaches the threshold, about 10 million degrees. At that unimaginable heat, the hydrogen at the center can do something it could never do before. The nuclei of hydrogen, normally pushing each other apart, are driven together so hard that they fuse, 4 of them joining to make a single nucleus of helium and releasing a flash of energy. This is nuclear fusion, the fire that powers every star. Once it begins, the core pours out light and heat from within, no longer merely warmed by falling, but truly burning. The new light pushes outward against the infalling gas and finally halts the collapse. The star stops growing. It has found its balance and its size. In that moment, a star is born. Its fierce new wind begins to blow away the last of the cocoon, and for the first time its light shines out freely into space. Over the next stretch of time, the new star clears the space around it. Its wind and light sweep back the leftover gas, and the star emerges shining from the cloud that made it. Around it, the flat disk of leftover dust may still turn, and in that disk, over millions of years, grains can stick together into pebbles, rocks, and at last whole worlds. The star takes its place among its siblings, the other stars born from the same cloud. For a while they glide together in a loose and glowing cluster. In time, the cluster loosens and the stars wander apart, each to its own long path around the galaxy. Our star sets out alone, newly lit, into the dark. And now the long part of its life begins, the steady, shining ages that will last for billions of years. We will follow it there next into the quiet of its long day. Before we go on, let us pause here a while, floating in the deep quiet of space, with the new star glowing softly nearby and the dark stretching away on every side. There is nothing to do here but breathe. Feel how vast and how silent it is out here. No sound can cross the emptiness between the stars. There is only the slow turning of distant light and the deep, even dark. Out here there is no hurry. The stars keep time in billions of years, and a single night of yours is far too small for them even to notice. You can let your own time slow to match the dark. Let your breath grow long and even, like the slow burning of a star. Let your thoughts thin out into the quiet and your body settle, weightless, into the dark. In a moment we will follow our star into the long, steady years of its life. But there is no rush. Stay here in the quiet of space and let your breath grow slow. Now our star enters the longest and steadiest part of its whole life. For age after age it will simply shine, changing very little, burning hydrogen into helium deep in its core. Astronomers call this the main sequence, and a star spends about 9/10 of its life here. It is the long, quiet adulthood between a star's fiery birth and its distant end. Through all these ages, the star holds a perfect balance. Its own gravity is forever trying to crush it inward, and the outward push of its fusion fire forever holds it up. Gravity pulling in, light pushing out, matched so exactly that the star neither swells nor shrinks. This quiet standoff is what makes a star steady, and what lets it shine so long. So for billions of years the star burns on calm and bright, while worlds may form and turn around it. Let us look closely at one such star, the one we know best of all. The nearest star to us, and the only one we see by day, is the Sun. It is an ordinary star, middle-sized, middle-aged, yellow-white, and it is the steady fire at the center of our world. The Sun is about 4.5 billion years old, and roughly halfway through its life. For all that time it has burned with hardly a flicker, holding the planets in their long orbits. In its core, every single second, the Sun turns some 600 million tons of hydrogen into helium. The light of that fire takes 8 minutes to reach us and warms the whole Earth. Its heart is around 15 million degrees. Its surface a mere 5,500. Even that cooler surface seethes and boils with great cells of rising fire. And the Sun is only one ordinary star among the hundreds of billions in our galaxy alone. Every one of those points of light is a sun in its own right, burning in the same long way. It is worth pausing on how astonishing a star's steadiness is. A bonfire burns out in a night. A star burns for billions of years. How can anything keep a fire going so long? The answer is its own great mass. A star holds an almost unimaginable store of fuel, and its crushing gravity feeds that fuel into the fire only as fast as the balance allows, never all at once. The balance even mends itself. If the fire burned too hard, the star would swell, cool, and slow the fire. If it dimmed, the star would shrink, heat, and stoke it again. It is self-correcting. So a star is not a wild blaze, but a deeply governed one, a fire kept in check by gravity itself, parceled out across billions of years with great evenness. This is why the night sky seems changeless to us. The stars burn so slowly by their own vast clocks that a whole human life is far too short to see them change at all. Look closely at the stars on a clear night, and you will see they are not all the same color. Some shine faintly blue-white, some warm yellow, some a deep ember red. A star's color tells its temperature. The hottest stars, blazing at 30,000 degrees or more, burn blue-white. The coolest, around 3,000, glow a soft red. Our sun, at 5,500 degrees, sits in the middle, shining a calm yellow-white. It is, in the language of stars, an ordinary and steady kind. So the colors scattered across the night are a quiet map of heat, blue for the fierce and hot, red for the cool and gentle, with every shade between. And color hints at fate, too. The hottest blue stars, as we will see, burn the fastest and die young. The cool red ones burn slowest and live almost forever. Stars come in a great range of sizes, and a star's mass, how much matter it holds, decides almost everything about its life, how it burns, how bright it is, and how it will end. The largest stars, the supergiants, are so vast that if one stood where the sun stands, it could swallow the orbits of the inner planets whole. They are rare and brilliant and brief. The smallest true stars, the red dwarfs, are dim and cool, far smaller than the sun. They are also by far the most common stars in the universe. Between these extremes lies every other kind, including our own steady yellow sun, comfortably ordinary, neither giant nor dwarf. It seems strange, but the biggest stars live the shortest lives. To understand why, and to meet the longest-lived stars of all, we turn first to the small and slow-burning red dwarfs. The red dwarfs are the small, cool, faint stars, so dim that not one of them can be seen from Earth with the naked eye, though they are the most numerous stars there are. Because they are small, they hold less fuel, but because they are also cool and sparing, they burn that fuel astonishingly slowly, sipping rather than blazing. So a red dwarf can shine for an almost endless time, for trillions of years, far longer than the universe has yet existed. Not one red dwarf has ever died of old age. They also mix themselves thoroughly as they burn, using nearly all their fuel rather than only their cores, another reason their lives stretch so far into the future. Long after the sun is gone, long after the bright stars have all burned out, these small red embers will still be glowing in the dark, the last stars left shining in the night. Let us pause again and simply rest under the steady light of a star in its long prime, the calm, even shining that can last for billions of years. There is nothing here that asks anything of you. Think how much steadiness there is in a star. Through all the ages of its long life, it barely changes, holding its quiet balance, shining on and on without strain. Let that evenness reach you. Your breath can grow as steady as a star's light, slow and unhurried, in and out, while the day's small troubles thin away into the dark. There is nothing to hold on to out here, and nothing to carry. You can let your weight go entirely and drift, held by the deep calm of space and the quiet shining of the stars. Soon we will follow our own star toward the great change that waits for it at the end of its long day. For now rest under the steady light and let yourself grow heavy with sleep. For billions of years, our star burns the hydrogen in its core, but that fuel is not endless. Slowly over ages, the core fills with helium ash, and the hydrogen there runs low. When the core can no longer burn, the long balance begins to fail. With the fire at the center fading, gravity is no longer fully held back, and the core starts to contract. As the core squeezes inward, it grows hotter than ever before, and that rising heat reaches the fresh hydrogen in a shell just outside the core, which had never been hot enough to burn. Now that shell catches fire. A new fusion burns in a thin layer around the dead core, and it burns fiercely, pouring out far more heat than the old steady core ever did. That fierce new heat will change the star utterly. It is the beginning of the end of its long, steady life, and the start of its swelling into something vast. The fierce shell burning pushes the star's outer layers outward, and the star begins to swell, slowly at first, then enormously, growing far beyond its old size. As those outer layers spread out, they cool, and as they cool, they redden. The star, once a steady yellow-white, becomes a vast and ruddy globe. This is a red giant. It can swell to hundreds of times its former width, a bloated, glowing sphere, cool at the surface, yet blindingly large, with a tiny, fierce core hidden deep within. It is a strange reversal. The star grows huge precisely because its center is failing. The dying of the core is what drives the swelling of the whole. Our own sun will become such a giant in about 5 billion years, and when it does, it will reach out across the space where the inner planets now peacefully turn. When the sun swells into a red giant, the closest planets will lie within its reach. Mercury, the small first world, will be swallowed whole into the growing star. Venus, the second, will follow it into the fire. The bright morning star, wrapped in its thick clouds, will vanish into the swollen body of the sun. The Earth's own fate is less certain. The sun may reach its orbit or fall just short, but either way our world will be scorched bare, its oceans long boiled away. All of this lies billions of years ahead, far beyond all human time, and nothing to fear tonight. It is simply the slow and natural way that a star like ours grows old. And as the giant phase goes on, deep in that swollen star, the failing core is being squeezed toward one more threshold and one more kind of fire. Deep in the red giant, the core of helium ash is squeezed ever tighter until it too reaches an enormous heat, around 100 million degrees, 10 times hotter than the old core ever was. At that heat, the helium itself can burn. 3 helium nuclei fuse together into carbon, and some carbon takes on one more to make oxygen, the very stuff of life forged across the void. So a second great fire is lit, deep inside the dying star. For a time the giant steadies again, now burning helium in its heart and hydrogen in a shell around it. But helium is a far poorer fuel than hydrogen, and there is far less of it. This second fire burns fast and cannot last long, only a small fraction of the star's long life. When the helium too runs low, the star has no greater fire to turn to. for a star the size of our sun, the end is now near, and it will be quiet and strangely beautiful. Near its end, a sun-like star grows restless. Its two fading fires flicker out of step, and the great swollen star begins to pulse, swelling and shrinking, slowly, like a vast, slow breath. With each great pulse, the star's hold on its own outer layers loosens. Its gravity is weak at such a vast size, and its light pushes hard from within. And so, breath by breath, the star begins to let go of its outer self. Great shells of gas lift away from it and wander outward into the surrounding dark. There is no violence in it. The star simply exhales its outer layers, slowly and in rings, until much of its substance is floating free around it in the cold. And as those outer layers float away, they uncover something at the center, the small, fierce, naked core of the star, blazing hot and blue-white. The naked core left behind is searingly hot, and its fierce light pours out into the shells of gas the star has shed and sets them aglow. The result is one of the loveliest sights in the heavens, a glowing ring or shell of colored gas lit from within, hanging in space around the tiny dying star. We call it a planetary nebula. They take a great variety of shapes: rings, hourglasses, soft glowing spheres, delicate butterflies of gas, each one the gentle scattered remains of a sun-like star. The name is an old mistake. They have nothing to do with planets. Early watchers through small telescopes thought the soft round glow looked like a faint planet's disk. A planetary nebula does not last. Over some tens of thousands of years, the glowing gas spreads, thins, and fades back into the dark, leaving only the small dead core behind. Let us linger here a moment beside the soft glow of a planetary nebula, where a star is serenely giving up its outer self in shells of colored light. There is no fear here, only a slow letting go. There is a strange peace in this kind of ending. The star does not struggle, it simply releases what it held, breath by breath, into the wide and waiting dark. And nothing is truly lost. The gas floating away carries the very atoms the star has made out into space, where one day they may help to build new stars and worlds. Let that ease of letting go reach you. Whatever the day asked you to hold, you can release it now, the way the star releases its light, softly and without holding on. In a moment we will follow the small core that the star leaves behind into its long, cooling rest. For now, stay beside the glowing nebula and let your breathing ease. When the nebula has drifted away, one thing remains: the bare core of the star. It no longer burns at all. Its fires are spent, yet it still shines, white hot with the heat of its long life. This is a white dwarf. Into a ball no larger than the Earth is packed roughly half the mass of the entire Sun, squeezed to an almost unthinkable density. It is so dense that a single teaspoon of its matter would weigh many tons here on Earth. The atoms within are crushed together far tighter than any ordinary stuff. Nothing holds it up by burning anymore. Instead, it is held against its own crushing gravity by the sheer crowding of its packed particles, a strange, cold kind of support. The white dwarf makes no new light. It only glows with leftover warmth, an ember pulled from the fire, and now it will do the one slow thing left to it. It will cool. With no fire to renew it, the white dwarf simply radiates its heat away into space, growing slowly cooler and dimmer over enormous spans of time. The cooling is unimaginably slow. It takes billions of years for a white dwarf to fade from white hot through yellow to a dull and sullen red. In the end, after far longer still, it will fade to black, a cold, dark, dead star, a black dwarf, giving off no light at all. And here is a quiet wonder. No black dwarf exists anywhere in the universe yet. The cooling takes so long that in all the time since the first stars, not one white dwarf has finished it. So our sun's distant fate is this, not a grand explosion, but a long, slow fade, a small white ember cooling in the deep for longer than the universe has yet existed. Something remarkable happens deep inside a white dwarf as it cools. Its core is made mostly of carbon and oxygen, the ash of the helium fire, packed under crushing pressure. As the star slowly loses its heat, that packed carbon and oxygen begins to settle into an ordered pattern. It begins, in effect, to freeze and to crystallize. Over ages, more and more of the star turns to crystal, until much of it becomes a single vast ordered lattice of carbon, a crystal the size of a planet. Because that crystal is carbon, packed and ordered, some have described these cooling stars, a little poetically, as diamonds the size of worlds, drifting in the dark. So the long ending of a sun-like star is not bleak. It leaves behind a slowly cooling, slowly crystallizing jewel, a quiet, glittering ember of all it once was. Not every star ends so quietly. The most massive stars, those born with many times the sun's matter, live wholly different lives and meet wholly different ends. A massive star is blue-white and blindingly bright, pouring out the light of tens of thousands of suns. It holds vast fuel, but it burns that fuel with reckless speed. Where our sun will live 10 billion years, a great star like this may live only a few million. The brighter the star, the faster it spends itself, and the sooner it dies. It races through the same first step as any star, burning hydrogen to helium, but in a fierce rush. And when its core hydrogen is gone, it does not simply fade. Instead, it presses on to burn things our sun never could. Its core grows hot enough to fuse heavier and heavier elements, one after another, in a deepening fire. As each fuel runs out, the great star's core contracts, heats, and ignites the next. Helium fuses into carbon, carbon into neon and oxygen, on and on into heavier elements. The star comes to burn in nested shells, like the layers of an onion, hydrogen in the outermost, then helium, carbon, oxygen, and heavier still toward the center. And each new stage burns faster than the last. Where hydrogen lasted millions of years, the burning of carbon may last centuries, and the final stages only days. The star is racing now, tearing through its remaining fuels in a quickening blaze, building up a core of heavier and heavier ash at its center. At the very center, that ash is becoming iron, and iron, as we will see, is where the long climb of fusion finally fatally stops. All through a star's life, fusion has given out energy. Each joining of light nuclei into heavier ones released a little heat that held the star up against gravity. But iron is different. Iron is the most tightly bound of all the elements, and fusing iron does not release energy. It costs energy, drinking heat in rather than giving it out. So when the core becomes iron, the fire that held the star up suddenly has nothing left to burn. The great outward push falters and in an instant fails. For the whole life of the star, gravity has been held at bay. Now, with the fire gone from the core, gravity is met by nothing at all, and it takes hold completely. What follows is one of the most violent events in all the universe, and yet it will seed the cosmos with everything needed to build worlds and life. We turn to it next. With its iron core unable to burn, the massive star has lost the fire that held it up. In less than a single second, the core gives way and falls in upon itself. The fall is almost beyond belief. A core larger than the Earth collapses to a ball only a few miles across in the time it takes to blink, its matter rushing inward at a fair fraction of the speed of light. The infalling matter is crushed so hard that the very atoms break. Electrons are forced into nuclei, and the core becomes something new, a ball of solid neutrons, denser than anything imaginable. And then, abruptly, the collapse stops. The neutron core cannot be squeezed any further. It becomes suddenly fiercely rigid, and the matter still raining down slams into it. That sudden stop sends a shock racing back outward and unleashes the most violent explosion the universe knows. The star is about to become a supernova. The rebounding shock, helped by a vast flood of ghostly particles called neutrinos pouring from the core, tears the star apart from the inside and blasts its outer layers into space. For a few weeks, the dying star blazes with the light of billions of suns, bright enough for a time to outshine its entire home galaxy of hundreds of billions of stars. Such a death is rare and brief, yet the sky keeps a record of them long ago. Watchers on Earth saw new stars flare up by day and fade over months, supernovae written into old chronicles. Where the star once shone, an expanding cloud of glowing debris is left, a supernova remnant, spreading outward for thousands of years in delicate luminous filaments. It looks at first like pure destruction, but this blast is also the greatest act of creation in the cosmos, for in its fire, the richest elements of all are forged. All through its life, even the greatest star could build elements only as heavy as iron. The metals beyond iron, silver, gold, lead, and more, need more energy to forge than any quiet star can give. The supernova provides it. In the searing heat and crushing flood of particles of the blast, nuclei are slammed together to build the heavy elements in moments. The gold in a ring, the silver in a coin, much of the heavy metal in the earth itself, all of it was forged in the death of stars and flung out into space by their final blast. So the most violent ending in the universe is also its great forge. What the star spent its life building, and what only its death could make, it now scatters generously into the dark. That scattered, enriched gas drifts out among the other clouds, carrying the seeds of future worlds and of everything that might one day live on them. Let us stay here a while, drifting in the soft glowing remnant of a star that has died among delicate filaments of luminous gas, spread gently across the dark. The violence is long past, only the glow remains. There is a strange calm here after so great an ending. The wild blast is over, and what is left drifts slowly, cooling and glowing, in no hurry to go anywhere. And all around you in this soft wreckage are the makings of new things, the very atoms that will one day gather into stars, into planets, perhaps into living things. Let the quiet after the storm reach you. Whatever was loud in your day is settling now, the way this glowing gas settles into the dark. You can let it drift and grow still. Soon we will meet the strange, dense thing the blast leaves at its very center. For now rest in the soft remnant and let your breath grow slow. At the heart of the blast, the crushed core remains, the ball of solid neutrons the collapse created. It is one of the strangest objects in all the universe. Into a sphere only a dozen miles across, the size of a city is packed more matter than the entire sun. It is almost unimaginably dense. A single sugar cube of neutron star matter would weigh about 1 billion tons here on Earth, as much as a mountain, crushed into a cube you could hold. Its gravity is so fierce that the whole star is almost perfectly smooth. Its tallest mountains may stand only a fraction of an inch high. It is a ball of pure crushed strangeness. And many neutron stars are spinning, often dozens or even hundreds of times every second, carrying the whirl of the great star that collapsed into them. A spinning neutron star often has a fierce magnetic field, and from its two magnetic poles it fires twin beams of light and radio waves out into space. As the star spins, those beams sweep around like the beams of a lighthouse, and if one happens to sweep across the Earth, we see a tiny pulse of light again and again with astonishing regularity. We call these spinning beacons pulsars. Some pulse so steadily, many times a second for years on end, that they keep time more precisely than almost any clock made on Earth. When the first was found, its pulse was so perfectly regular that, for a little while, some wondered if it might be a signal from another world. It was instead a dead star spinning in the cold. So even in death, a great star can keep a kind of heartbeat, a steady, sweeping pulse of light, marking out the seconds in the silence of space. For the very greatest stars, even a neutron star cannot hold. When the collapsing core is heavy enough, nothing in nature can stop its fall, and it keeps collapsing without end. The matter shrinks to a point, and around it gravity grows so strong that not even light can escape. Where the core fell, there is now a black hole. A black hole gives off no light of its own. It is a piece of the universe from which nothing returns. We see it only by its pull and by the glow of matter swirling in before it falls. Around it lies a boundary called the event horizon, the edge beyond which there is no coming back. Cross it, and not even light can climb out again into the night. It is the quietest and most final of all, a star's endings, a deep, still dark left where a brilliant giant once blazed, and yet even this is part of the long, turning story of the stars. Let us pause here, at a safe and quiet distance, near the still dark center that a great star leaves behind. There is nothing to fear from here. We only watch and rest. There is a deep stillness in these endings. The neutron star spins in silence. The black hole rests in perfect dark. The great fury that made them is wholly spent. It can be restful to think of such stillness, places in the universe so calm and final that nothing stirs them, holding their quiet for ages beyond counting. Let that deep calm settle over you. There is nothing here you must do, nothing to reach for. You can let yourself grow as still and quiet as the dark between the stars. Soon we will turn from these endings to a gentler truth, that all this scattered star stuff becomes, in time, the very matter of new worlds and of us. For now, rest in the stillness. Here is perhaps the most wonderful truth in all the science of the stars. The atoms that make up your body were not made on Earth. Almost all of them were forged inside stars. When the universe was young, it held almost only hydrogen and helium, the two lightest gases. Every heavier atom, every one was built later, inside the fires of stars. The carbon in your cells was forged in the helium fire of dying stars. The oxygen you breathe was made there too. The calcium in your bones, the iron in your blood, all of it star-made. And the heaviest atoms in you and in the earth were forged in the blast of supernovae, flung across space, mingled into new clouds, and gathered at last into our world and into us. So we are quite literally made of the ash of old stars. The light overhead at night is not separate from us. It is our distant kin and our common origin. When a star dies and scatters its substance, none of it is truly lost. The enriched gas wanders out and slowly mingles with the cold clouds between the stars. Those clouds, now seeded with the elements of old stars, are richer than the clouds of long ago, and one day somewhere within them gravity will gather a dense knot once more. And so the whole long story begins again. A new cloud collapses, a new core warms and ignites, and a new star is born, built in part from the dust of stars that died before it. Our own sun is such a later star. It was born from a cloud already enriched by earlier generations, which is why it has worlds of rock and metal around it, and why we are here at all. So the death of stars is not an ending but a turning, the old giving rise to the new. Light and dust pass down the generations in a great slow wheel that has no edge. We tend to picture each star burning by itself out in space, but our lonely sun is in a way the exception across the galaxy. Most stars are not alone at all. More than half of all stars are born in pairs or small families, 2, 3, or more stars bound together by gravity, circling a shared center for the whole of their lives. In a close pair, the two stars wheel around each other slowly, age together, and light each other's skies. From a world in such a system, two suns might rise and set. Such pairs are often mismatched, one heavier, one lighter, and so they age at different rates, the greater star reaching its end while the lesser still burns steadily on. And when two stars live so close, their fates can become entwined in strange and dramatic ways, as the dying of one reaches across to touch the other. In a close pair, when the heavier star swells into a giant, its outer layers can spill across to its companion, streaming from one star to the other in a glowing bridge of gas. Stranger still is what can happen to a white dwarf with a living companion. The small dead ember can draw gas from its neighbor, gathering it onto its surface over many years. Now and then that stolen gas builds up and ignites in a sudden flash, a nova, a temporary flaring of the dead star, brightening and then fading back to dimness. And if a white dwarf gathers too much, it can pass a fatal limit and detonate completely, a supernova born not from a giant's collapse, but from a dead star tipped over the edge. These exploding white dwarfs are so uniform in brightness that astronomers use them as measuring marks, reading the distances of faraway galaxies by their steady telltale light. Stars are not only born in pairs but in great gatherings. A single cloud can give birth to hundreds or thousands of stars at once, and for a time they travel together as a cluster. Young clusters are loose and blue, their hot new stars scattered across a patch of sky. The Pleiades, the little misty knot of stars in the winter sky, is one such young family. Over time, these open clusters drift apart, their stars wandering off to their own paths around the galaxy, as our own sun's birth cluster did long ago. But there is another, older kind, the globular clusters, vast, dense balls of hundreds of thousands of ancient stars packed into a glowing sphere and orbiting the galaxy in its outskirts. These globular clusters are among the oldest things in the galaxy, nearly as old as the universe itself, great cities of aged stars shining silently far above the galaxy's bright disk. Not every gathering of gas becomes a star. Some knots fall together but never grow quite heavy enough to kindle the fusion fire at their core. To become a true star, a body must hold at least about 8% of the sun's mass. Below that, the core never reaches the heat that hydrogen needs to burn. These in-between things are called brown dwarfs, too large to be planets, too small to be stars. They glow only dimly, with the leftover heat of their forming fading slowly over time. They are the failed stars of the universe, almost suns, that fell just short. Many float unseen in the deep, far too faint to notice without long and careful searching. And there may be a great many of them out there, dim, cool, and quiet, the shadowy cousins of the shining stars drifting between them in the long dark. Most stars shine with a steady light, but some are restless. They brighten and dim, swell and shrink in slow and regular rhythms, like a great slow pulse of light. Many of these are aging stars, grown unstable as their fuel runs low. They pulse in and out over days or weeks, their light rising and falling with the breathing of their outer layers. One kind, the Cepheids, pulse with a beautiful regularity, and the brighter ones pulse more slowly. That simple rule lets astronomers read their true brightness and so their distance. Because of this, these restless stars became measuring lamps for the cosmos. By them we first learned that other galaxies lie far beyond our own, across unthinkable gulfs of space. So even a star's unsteadiness can be a gift. The flickering of these restless suns gave us the first true measure of how vast the universe really is. Let us settle here a moment, drifting among the great family of stars, pairs and clusters, giants and dim red embers, all glowing softly across the dark. There is nothing to do but float here and look. How crowded and various the heavens are once you look closely. Few stars are truly alone. Most have companions, kin, a place in some greater gathering of light. There is a quiet comfort in that. The night sky is not a scattering of lonely points, but a vast community of suns bound together and gliding on through the dark in company. Let that company ease you. You are resting beneath a sky full of neighbors near and far, each one shining peacefully on. You need not hold anything, only glide among them and breathe. Soon we will visit a few of these stars by name, old friends of the night sky. For now rest among the many stars and let your breath grow slow. High in the winter sky stands Orion, and on his shoulder burns a deep red star, Betelgeuse. It is one of the few stars whose color you can see plainly with the naked eye. Betelgeuse is a red supergiant, so vast that, set where the sun is, it would swallow the orbits of the inner planets and reach out toward Jupiter. It is old and near its end. It has burned through its lighter fuels and is building toward an iron heart, the very path that leads at last to a supernova. One day, perhaps in 100,000 years, perhaps tonight, for its light is centuries old, Betelgeuse will explode and blaze in our sky bright enough to cast shadows. When it does, the great hunter Orion will lose his shoulder, and the sky will hold a new and temporary star, the death of a giant, written across the night. Of all the countless stars, one is closer to us than any other beyond the sun. It is a small, dim red dwarf called Proxima Centauri. It lies a little over 4 light-years away, so far that its light racing across space takes more than 4 years to reach us, yet it is the very nearest of all our stellar neighbors. Proxima is far too faint to see with the naked eye. Despite being so near, it is a cool, quiet red dwarf, the kind of small, enduring star that will outlast almost every other. And it is not alone. At least one small planet circles it, a world in the closest other system to our own. If we ever reach for another star, it will likely be this one first. So our nearest stellar neighbor is not a brilliant sun, but a quiet red ember, small, faint, and steadfast, glowing on and on just across the gulf. The brightest star in all our night sky is Sirius, the dog star, blazing white-blue low in the winter dark. It shines so brightly partly because it is both luminous and near. Sirius lies less than 9 light-years away. It burns hotter and brighter than the sun, a vivid white star that has drawn the eyes of watchers since the most ancient times. But Sirius hides a secret companion. Circling it is a small, faint white dwarf, the dead core of a star that was once the greater of the two, now a quiet ember beside its brilliant neighbor. So in Sirius we see 2 whole stages of stellar life at once, a bright star still in its prime, and beside it the cooling remnant of a star that has already run its course. It is a small lesson written in the brightest light of our sky, that every brilliant star is bound in time for the same quiet endings we have followed tonight. If the red dwarfs are the smallest stars, what are the greatest? The largest stars known are red supergiants and hypergiants of almost unbelievable size. The very largest are so huge that, placed where the Sun is, their surface would reach far past the orbit of Jupiter, swallowing the inner solar system many times over. Yet for all their size, they are thin and tenuous, their vast bulk spread into a glowing near-vacuum haze. They are great not in weight so much as in sheer swollen reach. And they are fleeting. Such enormous stars burn through their fuel in a geological blink, living only a few million years before they too collapse and explode. So the grandest stars are also among the most short-lived, brief, brilliant giants that flare across cosmic time and are gone, leaving the small dim dwarfs to outlast them all. Let us rest once more, under the familiar stars of the night sky, the ones with old names that watchers have looked up to for thousands of years. They are still there, still shining above you now. There is comfort in their constancy. The same stars that shone over the first people, over every life that has ever looked up, are shining tonight, unchanged within a human span. They ask nothing of those ancient watchers, and they ask nothing of you. They simply shine far off and steady, while the small world turns quietly beneath them. Let their steadiness settle you. You can lie here beneath the old familiar lights and let the day go, as countless others have done before you under these same stars. Soon we will look back to the very first stars of all, and forward to the far future of our own sun. For now, rest beneath the familiar stars and let your shoulders soften. Go back far enough and there were no stars. In its first ages, the young universe held only thin gas, hydrogen and helium, spread everywhere in a featureless dark. There was no light but a fading afterglow, and then not even that. For a long stretch of time, the cosmos was a cold, dark sea of gas with nothing shining anywhere within it. But the gas was not perfectly even. Here and there it was a little denser, and gravity, given enough time, began to gather those denser places without a sound together. Slowly, in the great dark, the first dense clouds formed and began to fall inward, just as star-forming clouds still do today, but for the very first time in the history of all things. And then, at last, the first fire was lit. Deep in one of those first clouds, a core reached the threshold, and the universe's very first star flickered into light. The first stars were unlike any that shine today, with only hydrogen and helium to build from, and none of the heavier elements. They grew far larger than the stars of now. They were giants, brilliant, blue-white and blazingly hot, pouring out fierce light into a universe that had never known any. They ended the long darkness. And they lived fast. Such massive stars burned through their fuel in only a few million years and died as the first great supernovae, scattering the very first heavy elements into space. Those first deaths seeded the cosmos with carbon, oxygen, and iron, where before there had been none. Every later star and every world was built on the ashes of these first ones. We have not yet seen these first stars directly. Their light has traveled to us across nearly the whole age of the universe, but the new great telescopes are reaching back, searching for their faint first glow. From those first stars onward, the universe filled with generations. Each generation of stars enriched the gas a little more, and from that richer gas the next generation was born. The oldest surviving stars, born early and poor in heavy elements, still shine in the outskirts of the galaxy, pale, ancient suns, nearly as old as time itself. The younger stars, like our Sun, were born from gas already enriched by many generations, rich enough in heavy elements to build planets of rock and metal around them. So the makeup of a star silently records its place in this long line. The old ones poor and plain, the young ones rich with the gathered leavings of all the stars that came before. We are very late arrivals in this story, children of a young, well-enriched star, made possible only by the countless stellar generations that lived and died before us. Stars are not scattered at random through space. They gather into galaxies, vast wheeling islands of hundreds of billions of stars, bound together by gravity and turning slowly in the dark. Within a galaxy, new stars are born mostly along its bright spiral arms, where the turning of the galaxy presses the gas together and sets fresh clouds collapsing. Our own galaxy, the Milky Way, quietly makes a few new stars worth of matter each year, a steady, modest birth rate kept up across billions of years. So a galaxy is a great slow factory of stars, forever turning, forever birthing new suns from old gas, even as its older stars age and die within it. And there are more galaxies in the universe than there are stars in our own, each one its own vast city of suns, turning serenely in the deep dark. On a truly dark night, far from any town, you can see our own galaxy overhead, a pale river of light stretching across the whole sky, soft and faintly glowing. That glowing band is the Milky Way seen from within. We live inside the galaxy's flat disk, and when we look along it, we see the massed light of countless distant stars blurred into a single soft glow. Every faint point in that river, and every smudge of light within it, is a sun, most of them too far to tell apart, their light merged into that gentle, misty stream. People have looked up at that river for as long as there have been people, and given it many names. It is the edge-on view of our own home among the stars. And our sun is simply one small star within it, one quiet light among the hundreds of billions that make up that pale river overhead. Let us rest here a while and simply take in the long view, the whole great wheel of the stars, from the first light out in space to the galaxies turning now. There is nothing to do but float and behold it. How long and how unhurried the story is. Stars are born, shine for ages and die. Their dust gathers into new stars, and the great wheel turns on slowly across billions of years. Set against such spans, the worries of a single night grow very small. The stars have kept their slow turning since long before you, and will keep it long after, and that is a restful thought. Let that long view ease you. You do not have to hold the day together. It can fall away, small and brief, beneath the slow and ancient turning of the stars. Soon we will come home to the future of our own sun, and then back down to the earth and to sleep. For now, rest in the long view and let your eyes fall shut. Let us return now to our own star and look ahead. The sun is in its calm middle age, about 4.5 billion years old, burning as steadily today as it has for all that time. But it is changing very slowly. As it fuses hydrogen, its core grows gradually denser and a little hotter, and the sun brightens by a small amount over each passing billion years. That slow brightening is gentle now, but over 1 billion years or so it will warm the earth too much for the oceans to remain long before the sun ever becomes a giant. None of this is near in any human sense, for all the time our kind has existed, and for vast ages to come, the sun is and will remain a steady, life-giving star. But its long day is not endless. Far ahead, the same path we watched other stars take waits for the sun as well, the swelling and the quiet ending. In about 5 billion years, the sun will at last burn through the hydrogen in its core. Then, as we have seen with other stars, its core will contract and its shell will catch fire. The sun will swell into a red giant, growing many times its present size, its surface cooling to a deep glowing red as it reaches outward across the inner solar system. Mercury and Venus will be swallowed. The earth will be scorched bare beneath a sky filled edge to edge with the vast red face of the dying sun. Then the sun will burn helium for a while, pulse in its old age, and gently shed its outer layers into space as a soft, glowing planetary nebula. And at the center of that fading nebula, the sun will leave behind its core a small, white-hot ember beginning the longest and quietest part of its existence. The ember the sun leaves behind will be a white dwarf, Earth-sized, immensely dense, and no longer burning, glowing only with the last warmth of its long life. Around it, the outer planets may still circle in the cold and dark, Jupiter, Saturn, and the distant worlds, orbiting a tiny white ember where a great golden sun once shone. And then the white dwarf will do the one slow thing left to it. Over billions upon billions of years, it will cool and dim and fade toward the dark. Far in the future, its carbon heart will crystallize, and it will become a cold, dark, crystalline ember, the last quiet remnant of the star that gave us all our days. So the sun that lights our every morning will end, in the unimaginable future, as a small dark jewel adrift in the cold, having shone by then for more than 10 billion years. Look far enough ahead, and even the galaxies will change. The gas from which stars are born is not endless. Little by little, it is being used up. In the far future, as the gas runs low, fewer and fewer new stars will be born. The bright blue giants will be long gone, and the galaxies will glow a deepening red with aging suns. Last of all will be the red dwarfs, the small sparing stars that burn so slowly. They will still be glowing faintly long after every other kind of star has died. And then, after spans of time beyond all imagining, even they will dim. The age of starlight will gently close, and the universe will grow quiet and dark once more. But that lies further ahead than the mind can hold, trillions upon trillions of years. For now and for all the time that matters to us, the sky is full of light. Think as the night deepens of all that the stars have given. From one ordinary star, the sun, come the light and warmth that make every morning, every harvest, every living thing on earth. From the deaths of older stars came the very atoms we are built from, the carbon, the oxygen, the iron, all forged in stellar fire and scattered for us to gather. And from simply looking up at them came much of our wondering, our first calendars and stories, our sense of time and direction, our oldest questions about where we are and how we came to be. The stars ask nothing of us in return. They simply shine and burn and scatter their light and dust, indifferent and generous across the long ages. To know even a little of their long lives is to feel more at home in the dark, to look up and see not cold and distant points, but our origins and our quiet kin. There is one last wonder to hold as you wander towards sleep. The light of the stars you see tonight is old, some of it very old indeed. Light is swift, but space is vast. The light of even the nearest star beyond the sun has been traveling for over 4 years, the light of many stars for hundreds or thousands. So to look at the stars is to look into the past. You see each star not as it is now, but as it was when its light set out, a window opening onto long ago. Some of the faint stars overhead may even have died since their light began its journey, and yet they shine on in our sky still, their last light only now arriving. So the night sky is a kind of gentle memory, the gathered light of countless suns across countless years, all arriving without a sound above you now. Tonight, when you next look up at a clear sky, you will see it a little differently. Each point of light is a sun, somewhere in its own long life. Some are newly lit, still clearing the clouds that made them. Most are in their long, steady prime, like our own sun. A few are old and swollen and red, near the ends of their days. And scattered among them, unseen, are the quiet remnants, the white dwarfs cooling, the neutron stars spinning, the soft nebulae fading back into the dark. The whole great cycle of stellar life is written across the sky at once, birth and prime and ending, all shining together in the night above your head. And you're looking up at it from a small, warm world that the stars themselves made, held safely beneath their light, ready now to rest. We have traveled far among distant stars. Let us come back now and look closely at the one we know best. Seen near, the sun is not a smooth yellow ball, but a vast, restless ocean of glowing gas. Its whole surface seethes and bubbles. Great cells of hot gas rise from below, spill their heat into space, cool and sink again, covering the sun in a shifting golden granular skin. Here and there, glowing arches of gas leap from the surface and curve back down, following unseen lines of force, vast loops, each one far larger than the whole of the earth. All of this is the outward face of the great fire within, the slow nuclear burning at the core, its heat carried up at last to the surface to be flung out across the solar system as light. It is humbling to remember that this restless, fiery ocean is only an average star, one ordinary sun among billions, and yet the maker of all our days and the warmth on every living thing. Sometimes the face of the sun is marked by darker patches, sunspots, each one a region where the sun's own magnetism has welled up and held back some of the rising heat. A sunspot looks dark only by contrast. It is still glowing fiercely hot. It merely shines a little less than the blazing surface around it, and so appears as a cooler, dusky island in the gold. These spots come and go in a slow rhythm. Over a cycle of about 11 years, the sun grows more spotted and more active, then calms again, then stirs once more, breathing in a long, steady beat. People have watched and counted these spots for centuries, tracing that long cycle across the years, the visible pulse of our star's deep magnetic life. Even the steadiest star, then, is not perfectly still. Our sun keeps its own slow seasons, its quieter years and its stormier ones, turning gently through them all. Now and then, where the sun's magnetism is most tangled, the tension snaps. A sudden flare erupts, a flash of light and energy brighter than anything else on the sun's face. Sometimes the sun flings out a great cloud of its own glowing gas, hurling billions of tons of matter into space in a single vast eruption that races outward among the planets. And always quietly, the sun is leaking. A steady stream of tiny particles flows out from it in every direction, the solar wind washing endlessly past all the planets, including ours. This wind and these storms fill the whole solar system with the sun's restless breath. The planets all swim within it, sheltered or buffeted by it out to the very edges of the sun's domain. Far out where the solar wind finally thins and meets the cold of interstellar space lies the true edge of the sun's reach, a vast invisible bubble blown by our star into the dark. Around the bright disk of the sun lies a faint, far hotter halo, the corona, the sun's pale crown, streaming millions of kilometers out into space in soft, feathery light. Strangely, this thin outer crown is far hotter than the surface beneath it, heated to millions of degrees by the sun's tangled magnetism in a way we are still working to fully understand. We cannot usually see the corona, for the brilliant disk of the sun drowns it out. It is hidden in plain sight, wrapped around a glare too bright to look past. But when the moon slides exactly across the sun, the bright disk is covered, and for a few short minutes, the pale crown blazes out around the darkness, one of the most beautiful sights in all the sky. In those rare moments, the hidden crown of our star is revealed, soft, silver, and vast, a reminder of how much of the sun reaches out unseen around the light we take for granted. When the sun's wind and storms reach the earth, our world is not left defenseless. The earth has a magnetic shield of its own, which catches the rushing particles and steers them toward the poles. There, high in the air above the far north and south, those particles strike the upper atmosphere and set it gently aglow, kindling the soft shifting light of the auroras. The auroras hang and sway like vast curtains in the night, green and rose and violet, rippling silently across the polar sky in slow luminous waves. They are, in their way, the sun touching the earth, the far-flung breath of our star, made visible at last as soft light dancing over the cold lands at the ends of the world. So even our storms and our shimmering polar lights are gifts of the same distant fire. One more way the life of a star reaches peacefully down into the life of our small world. Let us pause again and simply rest in the warmth of our own star. All its fire and storms and far-flung wind become, here on earth, only this, soft light and gentle warmth, and the steady round of day and night. There is nothing you need to do with any of it. The sun has risen and set faithfully for billions of years, and it asks nothing of you but to be warmed and to rest beneath it. Let that warmth settle into you now, like the last heat of the day held in a stone. You are safe beneath a steady star on a turning world under a darkening sky. Breathe slowly and let the light grow soft and dim around you. The sun is setting somewhere always and rising somewhere always, and it will be there when you wake. Soon we will look once more at how we have come to know the stars, and then drift on towards sleep. For now, rest warm and let your thoughts go quiet. Here is a quiet wonder. Nearly everything we know of the distant stars we have learned from their light alone. We have never touched a star, yet we know what they are made of. The secret lies hidden inside the light. When starlight is passed through a prism, it spreads into a band of rainbow colors, from deep red through gold and green to violet. And in that band of color are fine dark lines like missing notes in a chord. Each kind of atom in the star drinks up its own exact colors, leaving its own pattern of gaps in the light. So those patterns are like fingerprints. By reading the missing colors in a star's light, we can tell that it holds hydrogen or helium or calcium or iron, naming its ingredients from far away. It is a kind of quiet magic, and yet it is only careful looking. The stars write their nature into their light, and we have slowly learned to read it. The plain color of a star tells us something too, chiefly how hot it is. As with iron in a fire, the color of a glowing thing follows its temperature. The coolest stars glow a deep red like embers. Warmer ones shine orange and yellow as our sun does. Hotter still are the white stars, and hottest of all the brilliant blue. So a star's color is a thermometer we can read across the whole of space. A glance at whether it burns red or blue tells us at once something true about its fire. And color, with the dark lines hidden inside it, together tell us a star's heat and its makeup, two of the deepest facts about a sun, both carried softly in its light. From a single faint point in the night, then we can learn how hot it burns and what it is made of, a remarkable amount to know about something so unthinkably far away. But how do we know how far away the stars are? They give no sense of depth to the eye. They seem all fixed at the same great distance on the dark dome of the sky. For the nearest stars there is a gentle trick. As the Earth swings from one side of its orbit to the other across the year, a near star seems to shift, very slightly, against the far ones behind it. Hold up a finger and look past it with one eye, then the other, and it seems to jump. The nearest stars do the same small jump as the Earth moves, and the smaller the jump, the farther the star. By measuring that tiny shift with great care, we can work out the true distance to a star, distances so vast that light itself takes years to cross them. From that simple swaying view, step by step, we have built the whole great ladder of distance, measuring out the true depth of the heavens, star by star, into the far dark. Knowing a star's distance changes how we see its brightness. A star may look dim only because it is far, or blaze in our sky only because it is near. Once we know how far a star truly is, we can work back to its real output, its true brightness, the full light it pours into space, whether or not much of it reaches us. And the surprises are great. Some modest-looking stars are in truth titans blazing with the light of many thousands of suns, dimmed only by their vast distance from us. Others that we cannot even see with the eye are quiet little embers close at hand, faint red dwarfs giving out only 1,000th of the sun's gentle light. So apparent brightness and true brightness are different things, and knowing both, how bright a star looks and how far it lies, lets us weigh its real and inner fire. When we gather many stars together and sort them by their color and their true brightness, a hidden order serenely appears, a great family portrait of the stars. Most stars fall along one broad band, the cool, dim red ones at one end, the hot, bright blue ones at the other, and steady suns like ours somewhere in between. This is the long prime of stellar life. Off to one side glow the giants and supergiants, cool yet brilliant, because they are so vast. To the other lie the white dwarfs, hot yet faint, because they are so small. In this one quiet picture, the whole life story of stars is laid out at once, where they spend their long prime, where they swell in age, and where they fade in death. It is one of the great maps ever drawn, not of any land, but of the lives of the stars themselves, read entirely from their color and their light. Rest here a moment, and think how gently all this knowing was won, not by force, but by looking, and looking again across long quiet nights at the faint light of the star. No one ever traveled to a star to learn these things. We learned them by care and attention alone, reading the colors and the slow small shifts in their light. There is something restful in that so much can be understood simply by paying close, kind attention to what is already there, shining quietly overhead. You need not understand any of it tonight. You can simply let the stars be what they have always been to sleepy eyes, soft, distant lights, keeping their quiet watch. Soon we will turn to the moving sky and the patterns people have drawn among the stars, and then go gently down toward sleep. For now rest and let your breathing slow. For a long time we wondered whether other stars had worlds of their own, or whether our sun, with its family of planets, was somehow rare and alone in the dark. Now we know. Most of the stars you see at night carry planets, often several, turning silently around them, hidden in the glare of their suns. There are more planets in our galaxy than there are stars. Every point of light overhead is likely a sun with its own small worlds, its own little system wheeling in the night. So the night sky is not just a scattering of suns, but a scattering of whole worlds, countless planets we will likely never see, circling countless stars we can only just make out. Our own solar system, it turns out, is not a rarity, but one ordinary household among billions, one small family of worlds around one ordinary star. How do we find planets we cannot see, lost in the blaze of distant stars? Once again, we read the starlight and watch for the smallest changes in it. When a planet passes directly in front of its star, it blocks a tiny sliver of the light. The star dims by the faintest amount again and again, each time the world comes round. And a circling planet tugs gently on its star as well, making the great sun wobble by a tiny amount, a small swaying we can just detect in the star's light. From dips so slight and wobbles so small, we have found thousands of worlds around other stars, each one discovered not by sight, but by the faint mark it leaves on its sun's light. It is the same quiet method as ever. Look closely and longer at the light of the stars, and let them tell you in tiny signs what is circling them across the void. Around every star there is a band, neither too close nor too far, where a world might hold liquid water on its surface, not boiled away, not frozen hard. We call it the gentle zone of the star. Too near the star, a world is scorched and dry; too far, and it is locked in ice. But in that narrow, kindly band, water can stay liquid, and the conditions for life as we know it become possible. The Earth lies squarely within the sun's gentle zone, neither too hot nor too cold, and so our world has kept its oceans and its long, unbroken story of life. Around other stars, other worlds lie in their own gentle zones, quiet planets at just the right distance, perhaps with their own seas turning under their own suns. How many of those zones hold living worlds we do not yet know, but the places where life could take hold appear to be common, small temperate harbors scattered all through the galaxy. The worlds we have found are stranger and more varied than anyone imagined. The solar system, it turns out, shows only a few of the shapes a planet can take. There are giant worlds that hug their stars so closely their years last only days, their surfaces glowing with heat, far hotter than any planet near our own sun. There are worlds wrapped in endless cloud, and worlds that may be deep global oceans, and lonely planets drifting with no star at all, cast out to wander the dark between the suns. Some circle two suns at once, so that twin shadows fall across their ground, and two sunsets close their day, worlds with a double light in their sky. Each is a real place, somewhere out in the night, turning under its own sun or suns, a reminder of how vast and varied the family of worlds truly is. With so many stars and so many worlds and so many gentle zones, an old question returns softly in the cold. Are we alone, or is the galaxy peacefully full of life? We do not know. We have found no certain sign of life beyond the Earth, not yet, but we have only just begun to look, and the places to look are almost beyond counting. Whatever the answer, it is a wonder. If we are alone, then how precious and rare this living world of ours becomes. If we are not, then the galaxy is gently astir with other life. It is a good question to hold lightly as you fall asleep, not to solve, but simply to wonder at, beneath a sky that may hold more company than we have ever guessed. For now, it is enough to know that the stars are suns, that the suns have worlds, and that the night is far richer and stranger than it looks. Let us rest here a little, among all those quiet, distant worlds. Picture them turning slowly in the dark, countless planets, under countless suns, most of them never seen by any eye. There is something soothing in their number. Whatever happens here, the galaxy turns on, full of worlds and suns, calm and vast beyond all our small concerns. You are one small life on one small world among an uncountable many, and that is not a lonely thought, but a restful one. You are part of something immense and quiet and old. Let the size of it all hold you gently. There is nothing you must do about the galaxy tonight. It will keep turning full of light while you rest. Soon we will look at how the sky itself moves above us, and the patterns people have drawn among the stars. For now, drift among the quiet worlds, and let your thoughts go still. If you watch the night sky for a long while, you will see that it moves slowly, steadily. The whole field of stars floats from east to west, as though turning about the earth. But it is not the stars that turn, it is the earth carrying us with it. As our world spins, the stars seem to wheel overhead, rising in the east and setting in the west, just as the sun does by day. Through a long night, a star will climb the sky, cross it and sink again, while its neighbors follow in the same slow procession, the great turning of the heavens, marked out star by star. This is the oldest motion in the sky, watched by every people who ever lived. The slow wheeling of the stars has measured out the night since long before there were clocks. So even as you lie still tonight, you and the whole earth are turning gently beneath the stars, carrying you slowly round to face the morning sun once more. There is one point in the sky that hardly moves at all. As the other stars wheel through the night, one star stays nearly fixed, while the rest turn slowly around it. This is the pole star, set almost exactly above the Earth's northern axis. The Earth turns beneath it, so it alone seems to hold still while the whole sky circles round. Because it holds its place, the pole star has guided travelers for ages. It marks the north, faithfully, every clear night, a fixed point to steer by in a turning world. It is not, in truth, an especially bright star, nor will it always be the pole. Over long ages, the Earth's axis slowly shifts, and other stars take their turn as the still point of the sky. But for now, it is ours, the quiet, constant star, around which the whole night gently turns, and by which the lost have always found their way home. Among the fixed stars, a few bright lights do not keep their places. Night after night, they wander slowly against the steady patterns, the wanderers of the sky. These are the planets, our neighbor worlds, circling the same sun as the Earth. Because they are near and moving, they slide gently across the background of the far fixed stars. Unlike the stars, the planets shine with steady borrowed light, the reflected glow of the sun. They do not twinkle, but burn calm and clear, the brightest of them outshining every true star. People watched these wanderers for thousands of years, puzzling over their strange slow paths, until at last we understood we were watching other worlds moving with us around the sun. So a few of the brightest lights in your sky are not distant suns at all, but near companions, worlds like the Earth, sharing the long journey around our star. Long ago, looking up at the same stars we see tonight, people began to join them into pictures, to find shapes and stories in the scattered lights, and to give them names. A hunter, a great bear, a swan in flight, a hero, a river, the night filled with figures drawn in starlight, passed down from parent to child across the long generations. The stars themselves are not truly grouped. The stars of one pattern may lie at wildly different distances, only chancing to line up as seen from the Earth. Yet the patterns are precious all the same. They are among our oldest shared stories, a way of making the vast sky familiar, of turning the trackless dark into a place with names. When you find a familiar shape among the stars tonight, you are seeing the very same figure that countless others have traced before you for thousands upon thousands of years. The stars mark not only the night but the year. As the Earth travels around the sun, the sky we face at night slowly changes, and different stars rule the different seasons. Winter brings its bright, cold constellations. Summer brings another set entirely. The stars of spring give way to those of autumn in a slow wheel that turns once each year. So the returning of certain stars has always told the seasons, the time to plant, the time to harvest, the coming of the rains, written for us in the changing face of the night. In this way, the sky was the first calendar. Long before any written page, people kept the year by the slow procession of the stars across the seasons. The same great wheel still turns above you now. The stars of this season will fade westward in the months to come, and new ones rise to take their place as they always have. Rest a while now beneath the slow turning of the sky. The stars wheel overhead as they have for all of time, unhurried and sure, needing nothing from you but to be watched or simply to shine while you sleep. There is a deep comfort in their steadiness. The same stars your grandparents knew and theirs before them are turning above you now, faithful and familiar in the deep. Let that constancy hold you. Whatever has changed in your day, the sky keeps its slow ancient turning and will go on keeping it long after the day is forgotten. You do not have to follow the stars tonight. Let them wheel on without you. Let your eyes grow heavy and your thoughts float beneath their quiet, unfailing light. Soon we will draw near to the closest of all the stars beyond the sun, and then come home at last to sleep. For now rest under the turning sky and breathe slow. Vast as the galaxy is, our sun has its own small neighborhood, the handful of stars that lie nearest to us in the dark, our closest kin among the hundreds of billions. Even these near neighbors are unthinkably far. The nearest is more than 4 light years away, so distant that its light racing across space takes over 4 years to reach us. Between the stars lies almost perfect emptiness, light years of cold, quiet dark, with only the thinnest scattering of gas and dust wandering in the great spaces in between. Most of our near neighbors are quiet red dwarfs, too faint to see with the eye, small, cool embers glowing gently in the cold all around our brighter sun. So even our little corner of the galaxy is mostly soft, dim, and quiet, a scattering of small fires across an immense dark, with our own sun among the brightest of them. The closest stars to our own are a small family of three, bound together by gravity, circling one another out in the near dark, the nearest suns to the Earth. Two of them are bright golden stars, not unlike our Sun, slowly orbiting each other. The third is a small dim red dwarf, sailing at the edge of the group. It is that faint red companion that lies closest of all to us, the very nearest star beyond our Sun, a quiet ember just over 4 light years across the dark. And around that little red star circles at least one world in its gentle zone, the nearest of all the planets beyond our own system, so close and yet so utterly far. If ever we reach beyond our own solar system, it will likely be toward these nearest suns, the closest lights in all the sky, and still an almost unimaginable distance away. The stars are not truly fixed even to one another. Each one glides through the galaxy on its own slow path, and over long ages the whole neighborhood of the sun gently rearranges itself. So the stars near us now have not always been our neighbors, and will not always be. Some are slowly approaching, others are drifting away into the dark. Now and then, across millions of years, a star passes relatively close to the sun, brightening in our sky for a long age before sliding on once more into the distance. The patterns we see tonight, then, are only a passing arrangement, a single slow frame in a dance so vast and unhurried that to us it looks like perfect stillness. Give it enough time, and even the oldest constellations will blur and change as the stars wander on, each carried along its own quiet road through the turning galaxy. On a clear night you can find, with the naked eye, a small misty knot of stars, a tiny cluster, soft and close gathered, that has been loved and named by every people who saw it. These are the Seven Sisters, a true family of stars, hundreds of young suns born together from a single cloud, still traveling side by side through space. They are young as stars go, hot, blue, and brilliant, only a fraction of the sun's age, still wrapped in faint shreds of the cloud that gave them birth. In time they will glide apart, each going its own way through the galaxy, until the little cluster dissolves and its stars are scattered, no longer kin to the eye. But for now they hang together in our sky, a small jeweled cloud of young suns, one of the loveliest sights the unaided eye can find among the stars. Below the three bright stars of a famous winter pattern hangs a faint patch of light, soft and a little blurred to the eye. It is not a star, but a whole nursery of them. This is a great cloud of gas where new stars are being born right now, one of the nearest star nurseries to us, glowing with the light of the young suns kindling inside it. Within its glowing folds, dense knots of gas are collapsing into fresh stars, just as we watched at the very start of our story, birth happening even now in plain view of the eye. So when you look at that small misty glow, you are looking at creation still underway, a place where suns are being made tonight, far off in the cold of space. It is a quiet marvel that such a thing is visible from a garden or a field, that the birthplace of stars hangs there, faint but real, for anyone who looks up to find. Not everything between the stars gives light here and there. Dark clouds of dust drift across the glowing background, blotting out the stars behind them in great inky shapes. These are cold clouds of fine dust and gas, the raw stuff of future stars. Within their dark hidden cores, new suns are quietly beginning to gather unseen. So the dark patches in the Milky Way are not empty at all. They are some of the busiest places of all, dusty cradles where the next generation of stars is slowly taking shape. From within such darkness came the sun long ago, and every star you can see, the bright suns of today, were once hidden in clouds just like these. So light and dark work together in the sky, the shining stars and the dark clouds that without a sound make them both are part of the long turning life of the stars. Far out, beyond the flat disk of the galaxy, hang great spherical swarms of stars, globular clusters, each one a tight ball of hundreds of thousands of suns, bound close by gravity. These are among the oldest things in the galaxy. The stars within them were born early in the history of the universe and have shone together for many billions of years. Toward the crowded heart of such a cluster, the stars grow so dense that the night sky there would blaze with countless close suns, with hardly any true darkness at all. They circle the galaxy in great slow orbits, far above and below its disk, ancient cities of stars, keeping their tight gatherings across almost the whole age of time. To look at one is to look back nearly to the beginning, a dense, glowing swarm of some of the first stars that ever formed, still shining silently together out in space. On the darkest nights, far from any light, you can just make out a faint smudge of light in the sky, soft and oval and dim. It is the farthest thing the unaided eye can see. That faint smudge is another galaxy, a vast wheel of hundreds of billions of stars, much like our own Milky Way, gliding in space far beyond all the stars we can name. Its light has traveled for millions of years to reach your eye. You are seeing it not as it is now, but as it was long before there were people to look up at it at all. And it is drawing slowly nearer. In some far future age, our galaxy and that one will meet and merge, their stars sweeping past one another in a vast, slow, silent dance. To see it with your own eyes is to look across an almost unthinkable gulf, a whole other island of suns, hanging faint and steadfast in the night. Let us rest one more time now among all these lights, the clusters and clouds, the nurseries and the far galaxies, all glowing softly together in the deep dark of space. How full the sky is, once you know how to see it, not empty at all, but crowded with birthplaces and gatherings of stars and other galaxies beyond counting, all turning quietly. And all of it is calm. None of it hurries, none of it strains. The whole vast sky simply shines and turns and goes about its long, slow life, asking nothing of you at all. Let that calm settle deep into you now. You are held within all this light, a small warm life beneath a sky of countless quiet suns, safe and free to rest. We are nearly home now, and nearly at sleep. Let us come back gently from the far galaxies to our own star and our own small world and your own slow breathing in the dark. Before you sleep, hold one last thought close. Everything we have seen tonight, the nurseries, the giants, the long deaths, the scattered dust, is not truly separate from you. The iron that carries warmth through your blood was forged in the heart of an ancient star. The calcium in your bones, the carbon of your body, all were made in stars that died long before the sun. You are quite literally made of stardust, gathered out of the ashes of old suns, formed into a world, and then into living things, and at last into you, lying here in the deep. So when you look up at the stars, you are in a quiet way looking at your own distant origins, at the great furnaces where the very atoms of your body were first made. There is no need to feel small beneath the stars. You are part of them, and they of you, the same long story still unfolding in the dust and across the void and in your own slow breath. Let us come the rest of the way home now, back from the far galaxies, back past the near stars, back through our own solar system, to the small blue world turning serenely beneath the night. Here is the Earth, our home among the stars, a warm living world wrapped in air and water, lit by day by one steady star and watched over by night by countless distant ones. Down through the dark we come, to the quiet land below, to the soft night air, the still horizon and the gentle hush that settles over everything as the world turns toward sleep. The same sun that we followed through its whole long life is only just set, somewhere beyond the horizon, and will rise again, faithful as ever, while you sleep through the quiet hours. And here you are at the end of the journey, safe in your own small place beneath the turning stars, on a warm world the stars themselves have made. So let the day go now, as gently as a star lets go of its light. There is nothing left to do, and nowhere left to be, but here in the quiet, ready for sleep. Let your body grow heavy and warm. Let your breath come slow and even. Let the long story of the stars fade softly into the background of your floating, quieting mind. Above you, the stars keep their slow and ancient watch, as they have through every night that ever was, burning gently, turning slowly, asking nothing, simply shining while you rest. You are safe and small, and held within something vast and old and kind. The same light that fills the whole universe is shining softly over you. And so, beneath the quiet stars, on this warm and turning world, let yourself glide down, at last, into a deep and gentle sleep. So tonight, as you wander the last of the way down into sleep, you can carry one quiet thought with you. Far above you, beyond the clouds, countless stars are burning steadily in the dark, and you're resting safely beneath them. Somewhere out there, a new star is kindling in a cloud of dust. A steady sun is shining on its worlds, and an old star is giving the last of its light back to the night. None of it asks anything of you. The stars will keep their long, slow fires burning until morning, as they have for billions of years, while you let go and sink gently down into rest. Thank you for spending this hour with us. If this video helped you find rest, please subscribe. It is what allows us to keep producing long nights like this one. Slow visits through the quiet science of the stars and their long, luminous lives, voiced gently and meant for sleep. Good night. Outside this video, the night is still going. Far above you tonight, beyond the roof and the clouds, countless stars are burning in the dark, some being born in glowing clouds, some shining steadily as our own sun does, some giving the last of their light to the night, as they have since long before the earth was made. Tomorrow comes when it comes. Until then, sleep deeply. Good night from the Circadian Institute.